Thank you, everyone. So it's my goal to try to blow your minds this afternoon, so pay attention. Basically, my whole approach to this subject, which is kind of wrapped up in this idea of the physics of God, is that I looked for ways in which the kind of core promise of pretty much every religion in the world can be supported by science. So I kind of focused on a handful of those core promises. That there are miracles possible, that there is life after death, that there are heavens, that there is a God, and that personal transcendence is possible. And so I took those as the givens. The way I like to say it is that there is and can only be one reality. There can't be a reality for science and a reality for religion, or multiple realities for multiple religions. There can only be one reality. So if, as I do, you see the truth over and over again in the descriptions given by saints, you see the truths of religions as highly, highly likely, given the sort of compelling consistency of descriptions given not just by saints and sages and mystics, but by near-death experiencers. Oh, I'm sorry. Is anybody able to turn this up? We're working on it. Can no one hear me? But I'm not being amplified. A little bit. Okay, well, I'll try to speak up until I suddenly am really loud. So the compelling consistency of all of those sources really make me believe clearly and simply that all those things are true. So if they are true, and this is my starting point, if they are true and there is one reality, then somehow or another science has to support them. There has to be a connection there. There can't just be this vast gulf. Thank you. I think I got some sound. There can't be this vast gulf between these two. So I set about trying to identify the ways in which science supports these perennial truths of religion. And I found to my delight that there is very significant support for these truths. That it's not a stretch. You don't have to go find a obscure paper by some fringe scientist who has done a study that nobody else can duplicate to find the support. You can find the support in the heart of physics, in the heart of medicine, in the heart of neuroscience. You don't have to make big leaps. So I can't cover all of that ground in 45 minutes, but I thought I would intrigue you with a couple of sort of ways of thinking about things from a scientific point of view that mesh with spiritual teachings. So we're going to start with M theory. And M theory is a branch of string theory, which is a part really of quantum theory. We're going to go down the rabbit hole, and we're going to end up in heaven. So many of you have probably heard that there is a so far unbridged difference between the theories of relativity, the equations, the tenets of relativity, which Einstein was the founder or the discoverer, and those of quantum physics. And one of the biggest discrepancies between them is how much energy exists in space or in the universe. Now, they both need energy to exist in space in order for their equations to work. And they have varying purposes with positing that there is energy in space. So with Einstein, he discovered that in order for his equations of general relativity to work, he had to posit something called the cosmological constant. And the cosmological constant was simply him saying there needs to be about 6% of all the energy that there is just kind of exists in space. And unless I put that constant in there, then my equations don't add up to what is observed in the way the distant galaxies are behaving or black holes are forming. And so he picked this. He was very nervous about picking this kind of out of thin air. But he had no other way to resolve all of his equations. Now, later, it has been discovered that the cosmological constant that he chose is not a high enough level of energy to explain that the entire universe is expanding. So now we have this reality that was really discovered within the last 2 or 3 decades, that Einstein's original quantity of energy was too low to explain a universe that was not only expanding, but expanding at an accelerating rate. And so physicists came up with this notion of dark energy, some kind of energy that exists somewhere that is unmeasurable and they really don't know what it is. But unless they add that much larger amount of energy to this notion of the cosmological constant or to the notion of there being energy in space, then it doesn't add up to observed behavior of the universe. So for that reason, relativity has to have a bunch of energy in space. In quantum physics, they need a lot more energy than that to exist in somewhere. Because they have this notion, built on their mathematical equations, that in any given instant throughout the universe, there are what are called virtual particles. Oppositely charged virtual particles spring into existence, and because they're oppositely charged, they mutually annihilate each other and disappear. And that this is going on all the time. That the entire universe is this restless interaction of energy. And that's where the phrase quantum foam was born. And this is not just, again, a kind of a fanciful thought about the universe. It's warp and woof with quantum theory. That energy has to be there. It has to be behaving that way. Otherwise, the equations of quantum theory don't work. But there is as much as a difference of as much as 122 times between the estimates of quantum theory of how much energy there should be and relativity. This is a humongous discrepancy. And among other discrepancies between the two theories, that keeps them from being able to be reconciled. So along came string theory. So string theory is an attempt, among other things, but it is in large measure an attempt to find a kind of a third theory that can reconcile itself to relativity and then reconcile itself to quantum theory, and in that way kind of bridge the two. And it posits that there is a underlying reality throughout the universe of tiny vibrating rings and strings. And these rings and strings are as much smaller than the atom is smaller than we are. So they are a billionth the size of the atom, their wavelength. They're unmeasurable. They only exist as a theoretical concept. But in physics, the real king is math. And they work mathematically. So this gives a lot of physicists a strong feeling of confidence that if they can work out the math and they can make some key discoveries, that they will be able to prove out this basic assumption of string theory. So, because they're too small to be detected, they don't really know where they are. So, enter M theory. Oh, string theory too, excuse me. So this is fundamental to the argument, that this idea that there is this vast sea of energy, this substrate of energy everywhere, allows there to be some of that energy existing in the three dimensions that we are familiar with in what we think of as the physical universe, that would be enough to satisfy relativity's needs, and yet also allow there to be all this missing extra energy of quantum theory existing in other dimensions that are beyond the physical universe. So that's kind of the underlying unity of it. The energy is there, quantum theory is correct. There is 122 times as much energy as relativity needs, but most of it exists in dimensions beyond the three dimensions of the physical universe. So where are these other dimensions? And that's where M theory comes in. So M theory is perhaps the most respected, most accepted branch of string theory. And it posits that this extra energy, huge amount of extra energy, exists in brains. Now this is the first of several of extremely confusing and dull words that physicists have come up with to explain things. A brain is a contraction of a membrane. So a brain is something that divides, that has borders, that creates discrete sections. So they posit that there are numerous brains in this vast sea of energy that lies outside the three dimensions of the physical universe, and that they call the whole thing collectively the bulk. Now this is the second and even worse term that physicists have come up for something that is actually shorthand for the bulk of reality. So what they're saying is most of reality, by far, the bulk of reality, is in this unseen, unmeasurable realm of pure energy. But they call it the bulk. I much prefer to call it the energy verse. I'm probably the only person in the world who calls it the energy verse, but I like it much better. So the energy verse is so big that our entire physical universe floats in it like a bubble. And it is saturated. So unlike a bubble, which is sort of holding a container of air separate from the water around it, our universe bubble is also interpenetrated by this energy. So in that sense, you could say it's more like a sponge. You have the water saturating the sponge. The sponge has its own, distinct existence, but it's thoroughly interpenetrated with water. So our physical universe depends on that additional energy, but it doesn't rise to measurability. It doesn't come into the three dimensions with which we are most familiar. And this universe is so vast that it can hold basically innumerable other bubble universes. So M theory presents a view of reality that is mind-blowingly larger than what is generally already a mind-blowingly large physical universe. You read a lot of speculation about, well, the physical universe is so big that, it's got 200 billion galaxies in it, and it's so vast that light arriving from one side of the universe takes 13 billion years to arrive at this side. But it's a tiny bubble in this vast realm. So the reality that M-theory posits is really immensely bigger than that of just the physical universe. This is a quote that I found from Sri Yukteswar. This is in the autobiography of a yogi, where he says, "Spirit created planets, fresh bubbles of universes, wisdom stars, spectral dreams of golden nebulae, all over the sky blue bosom of infinity." So it's a sort of a poetic description of a soul's kind of moving through the cosmos. But I love the fact that in 1940, he was talking about seeing fresh bubbles of universes in the soul's unfettered journey through the cosmos. Now, there is a structure to the universe, to the cosmos, as posited by M-theorists. And the first aspect of it is that it's entirely two-dimensional. This is really hard for us to get our minds to wrap around, because almost everything we experience is in 3 dimensions. And our language is 3-dimensional. I said that the energy verse is incredibly vast. But is that really a meaningful term when it's only 2 dimensions? So there's a real dichotomy in trying to imagine that this 2-dimensional realm that holds the vast majority of energy that is posited to exist is holding it in these 2 dimensions. They also say that, and this sort of follows on the first, but they say that it is spaceless. So without that 3rd dimension, you can't have space. So you have an entire realm that has no space, and because it has no space, it has no matter. It has to fundamentally be pure energy. And I mentioned before, it's interpenetrating. That energy saturates our physical universe. It is everywhere within our physical universe. It's just so far below the threshold of us being able to detect it that, in a sense, it might as well not be there for the purposes of things like relativity. And lastly, it has this structure of multiple brains. And you can think of them as zones. And each one of those brains is a region of energy that vibrates more or less at the same frequency. So the higher the frequency, the denser the energy. So high frequency means small. So you get more energy packed into a brain when the frequency is higher. And what they posit, different versions of M-theory have different numbers of brains and different relationships between the brains. But basically they talk kind of generally about 6 or 7 of these layers. They actually use the visual metaphor of a loaf of bread with slices, and each slice is a brain. So this is the picture that M-theory gives us of the bulk of reality. It's pure energy, 2-dimensional, there's no matter. It's completely, if you want to think of it this way, it's completely light-filled. It's completely luminous with no space, no matter. And it interpenetrates our world, but is invisible to us because we can't measure it. And it has this layered structure. So now I'm going to ask you to take a leap with me, because I want to describe to you how the heavens are described by the saints, sages, and mystics, and near-death experiencers. They say it's two-dimensional. The heavens are two-dimensional. And I'll read these because they're such great quotes. Just as persons on the cinema screen appear to move and act through a series of light pictures and do not actually breathe, so the astral beings walk and work as intelligently guided and coordinated images of light. So the context of this quote is he's talking about the heavens, that people who are in the heavens are basically intelligently coordinated images of light. Further quote, this is from a near-death experiencer. Heaven is a world much like our own, except there is no time nor space as we think of them here. Heaven exists in a higher dimension of energy. One of the inspiring things for me when I kind of went down this path of seeing this connection between the cosmos as described by M theory and the heavens was that I found quote after quote, story after story, confirming this from near-death experiencers and the mystics. They also talk about it being interpenetrating, but interpenetrating in the sense that when you're in that role, when you're in that level of reality where you are just a luminous being, you are able to see and interact with the physical realm, but people in the physical realm can't see and interact with you. And thus we have this ability for what seem like supernal or mystical manifestations to happen. People see angels, young children see fairies, and people can see ghosts. Because of that interpenetration, they're not stuck in heaven and there's, never twain will meet. It's that they are warp and woof. It's only that your perception of them can happen rarely when those entities choose to kind of, in a sense, vibrate more grossly, vibrate more slowly, to be seen through the senses. All of the heavens, in all of the traditions that I was able to find, are multi-layered. This is a picture of, or an interpretation from the Islamic faith, that there's a famous passage in the Quran where Muhammad is taken up into heaven while he was sleeping. And he was taken up through 7 levels of heaven. And each level of heaven was higher, more exalted, more morally pure, more beautiful than the last, until he got to the 7th heaven. You'll find this in the Buddhist tradition. You'll find this in the Christian tradition. And another commonality they have is that each level supports, the higher the level, the more it supports the level below it. That level then in turn supports the level below it. Each one can't exist without the higher level above it. So the whole structure is required. You can't have, according to the principles of spiritual teachings or the principles of M theory, you can't have one without having all of them. That this layered aspect of them is intrinsic to the whole concept. So my leap, as you already have gathered, is that M theory is deducing the home of the heavens. That M theory is suggesting that this realm does exist. It's not the heavens are not a vague, poetic kind of reality, but they are a solid reality. just not a physical reality, and that there is a place for them in the cosmos. So hopefully that started to blow your mind. And let me keep going in that same vein and talk to you about the observer effect, or pressing play for the cosmic movie. So probably all of you have heard about the observer effect, the measurement effect, the intelligent observer effect. Anybody not run into this phrase? Okay, well, I'm going to give you a little tour. The only way I know to explain it without completely losing people is to just walk you through the series of experiments that were not necessarily conducted in a series. They were conducted over a couple of decades. But the learning process of the physicists who were doing these experiments led them to this conclusion of, or this acknowledgement of the observer paradox. So back in the 1920s, they were experimenting with the wave-like nature of light. And so they came up with an apparatus where you have an ordinary light source that, in this case, goes through a single slit to create a kind of narrowed channel of light, which then itself passes through two slits. And those two slits create two beams of light, two waves of light coming through. And then gradually, as those expand, they begin to interfere with each other like ripples on a pond. If you throw two rocks in, the ripples begin to mix with each other. And, what they found, again and again, was if you have a detector measuring the strength of the light coming through the two slits, that it gets higher energy, or a brighter line, which is where either troughs or crests meet. So where crests meet, they amplify, where troughs meet, they amplify, and you have more light energy. And then they had darker bands where crests and troughs would meet and basically negate each other and have no energy. So this proved conclusively that light behaves like a wave. Well, then later on, because of quantum physics, physicists discovered that there's also a particle form of light. And this is one of those aspects of quantum weirdness, right? So you've got light that can be a wave, you've got light that can be a particle. That's already doesn't make sense from our general sort of sensorial experience of reality. But they were able to develop a device that could emit one photon at a time. So somewhere in that process, somewhere in that process, thought, well, let's see what happens if we send photons through the double slits. And this is what they were all expecting to see, is that this little photon emitter would shoot out photons, and some would go through one slit and hit the detector, and some would go through the other slit and hit the detector. And that was, clearly what was going to happen, because they were particles. Well, this is actually what happened. Now remember, they're going through one photon at a time, and there's a period of time between them. So when you're talking about the speed of light, if you wait 30 seconds, it's like an eternity to send the next photon out through the device. But they would do this, get the experiment started. Sometimes they'd leave them running in isolation for days. And then they'd come back, and they'd look and see what they saw in their detector. And this was it. So this made quantum physics even weirder, because what was that single photon interfering with? With the wave pattern, you've got two waves. It's clearly one wave is interfering with the other. But if you've got a single photon, what is causing it to not just go straight through the slit, hit the detector, and make that vertical bar? So they didn't have any answer. They came up with a lot of speculation, and in fact, there's still a lot of speculation. But then they said, well, we're not really going to be able to solve this. Let's try to measure, for a starting point, let's try to measure which slit an individual photon went through. And maybe that'll give us some clue about how this works. So when they did that, that's what they saw. So suddenly they started seeing what they expected to see in the first place, but absolutely nothing was different in the experiment except they measured it. I love to see people's expressions when I go through that. I share your expression because it's still so confounding to what our minds tell us ought to happen. But this basic experiment has been repeated thousands of times, literally, and variations on it thousands of times. To the point where if you have a couple $1,000s, you can buy a little black box that will do that experiment for you, and you can run light through it any way you want and examine the results. But the inescapable conclusion that Niels Bohr and others, Niels Bohr is considered to be the father of quantum physics, the inescapable conclusion they came to is that an observer is essential for light to behave like matter. So you take the old saw, the old question, if a tree falls in the forest and there's nobody around, does it make a sound? Quantum physics says if a tree falls in the forest and there's no one around, there's no sound, there's no tree, there's no forest. There's nothing. So this is fairly fundamentally mind-blowing, right? That the energy that's there, and quantum physics isn't saying that the energy goes away. The light energy is still there, but unless it's observed, it doesn't behave like matter. And this has confounded everyone in physics through today. It's still viscerally difficult, even for physicists who have lived with this for all of their life, to accept this notion that somehow in some way, if there isn't a person involved, there is no matter. But they can't refute it because it happens every time they run the experiment. So that's the observer paradox. We're going to build on that as we zoom down another rabbit hole. This led physicists, this kind of acceptance of the observer paradox, led them to begin to think that the universe builds itself as a result of random observations. That, in a sense, what they were saying is energy could turn into anything. Energy could be, a hydrogen atom, a carbon atom. It could take any form. And it only takes the form that it takes because it's observed in a particular situation. So it suggests a very sort of random, not even evolutionary, but just a random process of creating the universe. And it suggests, well, I sort of said that, I'll skip it. So then it brings up, is the universe really created by chance? And this is another sort of fundamental debate in physics. Einstein famously hated this notion. And in his famous phrase, God does not play dice, was expressed his conviction that the entire cosmos, the entire universe, can't have formed accidentally. There must be what he thought of at the time, and it sort of fit the terminology of the time, there must be hidden properties. That somehow, even though we think that energy wave, or matter wave as they would refer to it, we think it is able to take on any form. There must be a little bit more information in there than we can find that tells that matter wave what form to take when it's observed. Unfortunately for Einstein, that was quickly disproven, because according to the fundamental principles and mathematics of quantum theory, you can't have quantum physics and hidden properties. You can't have both. You can't have quantum physics and hidden properties. You've got to either have quantum physics or have hidden properties. They're mutually exclusive. So in Einstein's lifetime, this was left hanging. And the sort of indeterminate view of reality had the ascendant. And today it pretty much still has the ascendant. But along about in the 60s, a professor named David Bohm, came up with several theories that allowed for the possibility of there being hidden properties, but instead of being kind of tied to a reality in the three dimensions of the physical universe, the hidden properties actually lay outside of the physical universe. So you can kind of put this together with what M-theory is telling us. M-theory is saying the bulk of reality, the bulk of energy that makes up the cosmos, lies beyond our physical universe. So David Bohm says, well, so therefore does the hidden properties. Those hidden properties could be in this pure energy realm. And he came up with a theory called the implicit and explicit order. So things existed, in his theory, existed in the implicate form in the energy verse, and then when they take form in the explicit realm, which is our three-dimensional physical universe, they assume three dimensions. So you don't observe it, it remains implicate. It remains in that potential, whatever form that is. You observe it, it comes into reality in three dimensions, but the properties of it are defined. He also came up with, or he didn't come up with, but he brought the mathematics of holography into his implicate and explicit order explorations, and it eventually went further than that. But basically what he saw was that the hologram, which is two-dimensional, creates the holographic projection, which is three-dimensional. We tend to use the term hologram loosely. You would say, oh, I saw this cool hologram. You weren't actually seeing the hologram. You were seeing the holographic projection. The hologram is flat. It's two-dimensional. It would be totally two-dimensional if it didn't have to be in some media, if it didn't have to be in film or in some kind of plastic substance in order to give it, hold it in this reality, if you will. But essentially, it doesn't need to be that fundamentally to act as a hologram. And when you shine coherent light through a hologram, coherent light is laser light, then it'll create a three-dimensional image, a three-dimensional holographic projection that you can actually walk around. It's not a three-dimensional image as we see on a television screen that looks three-dimensional. a holographic projection has actually got those 3 different dimensions. You walk around it, you see things on other sides of it that you can't see from that initial view. I've never personally seen this, but I love this story. I'm hoping it's not apocryphal. But somebody once told me they went to a museum and they had a cool program, really interesting program on like Paleolithic, no, that's too early. The last age when we had woolly mammoths and Pleistocene. Pleistocene, anybody know? Anyway, I got one nod. That they used these holograms very effectively to show woolly mammoths running through the tundra or whatever it was. And so you came into this hall and you sort of stood in the middle and all these holograms were around you demonstrating the past, and the announcer was at the far end of the hall waiting for you when you came in. And when the whole show was over, the announcer thanked everybody for coming and then disappeared because he was a holographic projection as well. So I'd love to see it, but haven't. But that notion of 2 dimensions able to create 3 dimensions became a foundation for Bohm's, what became known as Bohmian mechanics, which is a form of quantum mechanics. And then, because the mathematics was so interesting, M-theory took it and posited that the entire physical universe is a holographic projection. And that all the information, remember we had this missing information, right? We couldn't have these hidden properties. Suddenly what the M-theorists are saying is all that information is in the energy-verse. It's in this 2-dimensional realm, and the two-dimensional realm is itself luminous light energy, and it broadcasts, it's sort of its own projection system. So it's got the information, it's got the hologram, and it's got the light energy, and it projects the universe into being. This is fairly fundamental to M-theory. And all of these bubble universes that they're saying exist throughout the energy-verse are all holographic projections. This is how they explain it. Blowing any minds yet? Good, good. Well, hang on. So then the question comes up, well, what energy really is in the energy-verse? I have to go faster here. The M-theorists, who are, by nature cautious, don't want to make any claims for anything that they can't back up mathematically, they think the information that is in this 2-dimensional universe is the basic laws that make the universe work. So you have this collection of the basic laws. When it's projected into being, those laws go to work, and you end up with the Big Bang, and you end up with the universe expanding, et cetera, and you end up with us. Bohm would say that it is more form-like. It's not just the laws, but they're actually sort of elemental things, and that those basic forms are this 2-dimensional implicate that then become a 3-dimensional implicate. I don't think either one is enough information. And the main reason I don't think it's enough information is that the holographic principle suggests that our physical universe is being continuously created. If you turn the lights off on your holographic projector, the 3D image goes away. It can't just be sort of started and then you turn the projector off and go away. It can't just run on that. It is continuously created. So if it's continuously created, then there has to be a very complex, rich hologram that is behind it. And I think heaven is that hologram. I think the heavens, which are a complete world act as the hologram. It's a two-dimensional, perfect image that is then holographically projected into 3 dimensions. I'll read this quote. This is by Yogananda. "The blueprints of everything in the physical universe have been astrally conceived. All the forms and forces in nature, including the complex human body, have been first made visible in forms of heavenly light and vibratory energy." And another, "Everything was created of spirit matter before it was created physically. Solar systems, suns, moons, stars, planets, life upon the planets, mountains, rivers, seas, etc. The spirit creation would be like a sharp, brilliant print, and the earth would be like its dark negative." So again, I like to make the leaps. No self-respecting physicist would ever make that leap. But I don't have to be limited by that, because I'm not a self-respecting physicist. But I think the support is really there, that there is a ground to these spiritual teachings that is very persuasive. So I far overestimated how much I could tell you in 45 minutes. So I am just going to skip through a bunch of stuff, unfortunately, which I would have loved to share with you, about how virtual reality and the observer effect go together. But instead, I'm going to shift to the shameless commerce slide and invite you, if you want to perhaps go deeper into this, I have an online webinar. And sitting right here, Deva Leela has discount coupons. If anybody is seriously interested enough to want to take one, you get 20% off. 20% off. Online, you can come into it late and see everything that's already been recorded. And obviously, if you can't be there on a webinar night, you can watch it after it's been recorded. So thank you very much.